Hi, and welcome to 24 hours of past, 20 years of past learnings and future vision. We're excited you could join us today for Carlos Robles' session, Exploring SQL Server Containers on Docker and Kubernetes. This 24 hours of past consists of 24 live webinars delivered by expert speakers from the past community. The sessions will be recorded and posted online after the event. You'll receive an email letting you know when these are available. My name is Richard. I'm a DBA with a financial services organisation in the UK. I've got a few introductory slides before I hand over the reins to Carlos. If you require technical assistance, please type your request into the question pane located on the right-hand side of your screen and someone will assist you. This question pane is also where you may ask any questions throughout the presentation. Feel free to enter your questions at any time, and once we get to the Q&A portion of the session, I'll read your questions aloud to the speaker. You're able to zoom in on the presentation content by using the zoom button located at the top of the presentation window. Please note there will be a short evaluation at the end of the session, which will pop up after the webinar ends in your web browser. Your feedback is really important to us for future events, so please take a moment to complete this. I'd like to take a moment to thank our sponsors, Microsoft and Intel. The staging of 24 hours of PASS wouldn't be possible without their generous support, and they are the reason this event is available free of charge. If you would like to learn more about Microsoft or Intel and sign up for information on how they can help you, please visit the sponsors page of the 24 hours of PASS website. Keep learning all year long with PASS. Visit pass.org and check out all of the free educational resources available to PASS members. Also, don't forget that the PASS Summit 2019 will be happening on November the 5th in Seattle, Washington. Head over to passsummit.com and register today. This 24 hours of PASS session is presented by Carlos Robles. Carlos is originally from Guatemala and living in the US now for the past 3 years and has over 10 years experience in the database administration field. He considers himself a multi-platform DBA due to his experience on platforms such as Unix, Windows, Linux, Azure, and different database engines like MySQL, Oracle, SQL Server, and Azure SQL DB. Don't forget to check his blog where you can find SQL Server tips, best practices, scripts, and more. And without further ado, here is Carlos with Exploring SQL Server Containers on Docker and Kubernetes.
Hey everybody, good morning or good afternoon, maybe evening, depending where you are. As Richard said, my name is Carlos Robles and I'm very happy to be participating today in this 24 hours of PASS event. Okay, so let's take a look at what I have prepared for you guys today. A brief introduction to Docker. I'll be covering the basics of what the platform is and defining some of the most important elements. Then we'll take a look at the SQL Server Docker image and some basic information, what versions are available and where we can find it. Then we will take a look at the SQL Server Dockerfile because it's really interesting to understand how the Docker image is built, and this is just possible through the Dockerfile. Then a short example how to start a SQL Server container that will be addressed in details during the demo. Then a quick introduction to Kubernetes, same covering the basic, what the platform is, and defining most of the important elements. Then a quick demo of using SQL Server containers on Kubernetes. All right. So if you're ready, I believe most of you already heard about containers in some point. It's a really popular topic right now between IT professionals nowadays. And I think if you're attending this session, it's because you are probably curious to hear more about containers, what they are, how they work, and the most important, how you can integrate this new technology to your day-to-day DBA activities, right? So let's begin defining what is Docker. And this definition was taken from Docker Docs, and it says that Docker is an open platform for developing, shipping, and running applications Docker enables you to separate your applications from your infrastructure so you can deliver software quickly. With Docker, you can manage your infrastructure in some ways you manage your applications. All right, so let's define the very basic element of Docker. And let's start with images. And images is a read-only template created by using the Dockerfile that contains a set of instructions that will be executed to create a Docker container. In other words, it's a read-only binary file and it is built by a series of layers, and each one of these layers represents an instructions in the Docker file. And it's important to note that images are very portable and consistent across any platform. And also images are created from an existing image. For example, SQL Server is not exception. This image is created based on an existing image of Ubuntu or Red Hat. Now containers, what are these famous things that everybody's talking about? Well, container is just a runnable instance of a Docker image. It is nothing more than a program running on the host machine where the Docker daemon is running. And containers are also considered a standardized unit of software because if you remember from the previous slide, images are just instructions, a set of instructions in a file. So you can standardize your images through a Docker file. We'll see that in more details in the next slides. Containers also has a writable layer and a shared read-only layer. And I think we can understand that better from the graphic here on the right. We can see a set of containers using an image. In this example, it's an Ubuntu 15.04 image you can see here. And that's only possible because we are using the shared read-only layer. There is no need to create multiple images of the same. Multiple containers can use the same image at the same time. But what about the changes made at container level? So those changes are stored in the writable layer or of each container. And so you can guess this is a huge benefit in terms of storage utilization. If any of the containers is stopped, all the information will be stored in this writable layer. But in case the container is deleted, all the information will be gone. So we as DBAs will say, okay, that's kind of a problem for me. I don't want to lose all my files and everything. But there is a solution. Docker has something called volumes. There is multiple type of volumes, but in the most simple way, we can create a volume to point to a known path from the host machine where the Docker daemon is running. So all our data will be persistent no matter if a container is shut it down or deleted. We'll see a little bit more about that during the demo. Okay, now that we have the basic understanding of what an image is and what container is, let's take a look at the Docker architecture. As you can see from this graphic, Docker is built in the client-server model or kind of architecture where we have a main process called Docker D that runs in a form of a daemon. So that's why it's called Docker daemon. And this process can be running on a remote server or a local computer. And it's accessible through the network using command line commands by something called the Docker client. This client allows us to execute Docker commands against the Docker daemon. So we can build, we can run, or we can distribute Docker containers. The images are pulled from the Docker registry, and this can be either public or private. And in cases, you can even create your own registry that can be used only for people within your organization. We also have access to something called the Docker Hub, excuse me, that is a public registry that anyone can use. And we'll see how it works when using the Docker pull command later. And it is really important to note and I like this very much, that Docker runs in Linux, in Mac OS, Azure, or Windows. So it can run on any platform. All right, so you at this point you must say, okay, containers are good, but I'm already using VMs. So yeah, sometimes the when we can avoid to compare VMs with containers. So I put this comparison slide to show you the differences. Virtualization is basically a way to run multiple operating systems and applications on a single server, taking full advantage of the hypervisor processing power. But the problem is that each virtual machine will have all the hardware resources virtualized by this hypervisor, and also will include a full copy of its operating system or the application, plus the necessary binaries and libraries to run an application. So that ended up sometimes creating a heavyweight VM. In the other hand, containers run directly on the host machine, like any normal application process. No hardware virtualization is required. A difference than VMs, containers share the same operating system kernel. That means the virtualization occurs at operating system level, delivering better performance and efficient resource management. One of the great benefits is less storage. Another advantage of containers is that all the code, libraries, dependencies of one application are already installed and included as part of the container image. That means that we don't have to worry about that anymore. And we can even standardize our deployments. We can create on our own custom images. In our case, SQL Server, so we don't have to worry about installations anymore. Here is a comparison graphic, and you can see at glance the difference. We can run more containers on a Docker host than what we can run from a VM, because we have this guest operating system here at the bottom, so it's taking way some space. That doesn't happen here with containers. I'm not trying to say that containers are going to replace VMs. Each one will have their own purpose, but I'm saying it's efficient when running multiple applications at the same time. Okay, so a few advantages of using container. Well, the very first thing is that are really easy to use. You will see it during the demo. Another great advantage is that containers allow the agile creation of deployment and of applications. In this case, we're interested to see it for SQL Server. Due to their nature, containers integrate very well with continuous development, continuous integration, and DevOps workflows. Resource isolation and virtualization is pretty obvious because it's OS virtualization rather than hardware and software. Containers has a really quick start and stop time. You will experience more in the demo. Cloud and OS portability. And remember from the architecture slide when I mentioned that it can run on any platform. So this is really important. Environmental consistency across all platforms. And this is really interesting because a container created on a Mac OS can be saved, exported, and can be executed again in a Windows machine or even Azure. And when it says environmental consistency, also talks about standardization. And I don't know about you, but we as DBAs try to have our environments as healthy as possible in the best shape that we can. And we have to introduce some kind of best practices when installing or configuring SQL Server. But you don't have to worry about this anymore with containers, because you can create your own container that has all those modifications and you can have that image ready to go. And also containers has changed the way we used to patch SQL Server instances, and making this process a little bit fast and quickly. You'll see it. So I think that's a really good advantage. I don't know how about you, but sometimes we have to spend a large amount of time delivering SQL Server instances for development testing purposes, and we can avoid that using containers. Okay, a little bit about the SQL Server Docker image. Um, Probably by mid 2018, Microsoft has created its own syndicated central repository for containers. It is called Microsoft Container Registry. The goal of this new centralized repository is to have an only source for all the container images available on Docker Hub and also on Red Hat Container Catalog. This means that new images will be published at the Microsoft Container Registry, and all the existing containers images will exist on Docker Hub. Here's a little bit of like some kind of summary of what we can find about SQL Server images. We have the SQL Server 2017 image available just for Ubuntu, but you can find it from the RTM to the latest CU version. For SQL Server 2019, obviously CTP at this point, we can find images for Ubuntu and Red Hat, and the same from the RTM to the latest CU version. A great advantage, as I said before, SQL Server is pre-installed, so it's kind of standard. It is really important to note that backups are compatible between all platforms. So if I'm developing some solution on my container running on macOS, I can take a backup of that database and can be restored in a Windows machine or vice versa. So that's really important. Regardless the environment you are using, SQL Server will be transparent. Okay, so remember that I said that a Docker image is nothing more than a read-only binary file built up of a series of layers, and each one of these layers represent an instruction in the image Dockerfile. So this is it. We can see that the Dockerfile for SQL Server is composed of only layers of instructions, four instructions that made up a layer. Sorry, each one. And I grabbed this information from the Microsoft official GitHub repository for containers. You can see it yourself. And we can see that the image of SQL Server is based from, and in this case, it can be any, it can be Ubuntu or Red Hat, right? But this case is based on Ubuntu 16.04. And then the next instruction is saying, okay, container, I want you to use the port 1433. That, as we all know, that's the SQL Server default port. Then we have these copy instructions that will simply move all the files from the install directory to the root path on the container. Obviously, this copy operation was um, executed from the person who had all the binaries in his computer, and he just copy and paste everything into the container. And finally, we have this comment that gets SQL Server started, and it is just simply calling the SQL Server process using the instruction cmd. Okay, here is a short example how you can start a SQL Server container. As you can see, we don't have to provide too much details to the docker run command. In this case, I'm just saying, okay, I want you to use a name. That's a good practice for administration purposes. It makes everything easier when managing the container to stop it, to start it. Then a couple of environmental variables. The first one is accepting the end user license agreement. The second is to set the SA password for this container. Then I'm doing some mapping for the ports. I want to use the 1400 on my host machine, and obviously the containers weren't going to use the 1433. And finally, the detach command is going to say, okay, container run in the background. And then I'm just specifying the image I want to use. In this case, it's more 2017 CU13 for Ubuntu. In case this image is not on my local repository, Docker will be intelligent enough to download it from the internet. Depending on your connection, it will take some time. In my case, it takes a couple minutes. All right. So what happens once we complete this process? This is going to happen on the background on inside the container. The SQL Server process gets forked. Then these values from the environmental variables that we define are passed as the startup parameters for SQL Server. Then the var opt MS SQL structure is created and get populated. Then the system databases and files are extracted from in SFP files. And finally, the engine runs as a process. And that's it. Okay, so let's have a quick demo about a simple container. Just give me a moment here to hop back to, excuse me. Okay. I'll be using Visual Studio Code for my demos. Hope the resolution is good. All right. Okay, so this is what I'm going to do right now. I am going to start a container, then I will connect from Azure Data Studio to that container. I will run some basic Docker commands. I will connect through Bash inside the container. Then I will run a query using SQL command within the container. Then again, some basic Docker containers, and then I will delete it. Okay, so here's the instruction to create a container. Again, really basic. I'm just saying I want you to use the 20 years of past name, but I am also specifying the host name. I want the host name to be 24 years of past. In case I don't provide this parameter, it's fine, it's totally okay. But Docker is going to assign a random number, so I don't want that. I want to have a known name for my container host name. Then again, accepting the end user license agreement and putting a password for my essay. Super complex. I'm going to use the 2400 port in my host machine, and that will be mapped to 1433 to Docker. We need a container, and this is the image I'm going to use. It's a CU13412. So let's execute it. And that's it. I have a SQL Server instance up and running that I can use. And I'll prove you that I'm not lying. I have an alias. I have created an alias for the Docker ps-a that lists all the running containers. I just create a new one because I don't like the way this information is displayed on my screen. So I'll use it. Yeah, it's clear. Let me do it again. Right, so as you can see here, it says that the container called 20 years of pass, it's up and running for the last 30 seconds. And let's connect from the Azure Data Studio. Okay, so I have this query here. There you go. And I will connect to my 20 hours of pass. I already have this connection saved in advance, but if you can see, I'm connecting to my local host to the 1400 port, using the SA and putting the SA password. So let's connect. Okay, I'm in. Let's run this query. So as you can see, it's a normal SQL Server instance. Here's the instance name. It is mapped to my host name. It's an Ubuntu 16.04. I have 2 CPUs and almost 3 gigabytes of RAM. And let's explore it here from, there you go. Okay, it's connecting now. So it's an empty instance ready to use. And it took me just probably 5 seconds to create it. Right, so let's go back to Visual Studio Code. I'll close this for a moment. All right, so I will do basic management on my container. I want to stop it and I will restart it. So let's stop it. In order to stop this container, and I'll put the comments here, we just need to run the docker stop command, and then we have to pass the name of our container. All right, just really quick here. Yeah. Okay. So I'm stopping my container. It's done. Remember that I use this alias for the Docker active containers. So it returns this information, and it says my container called 20 years of pass was shut it down six seconds ago. So let's start the container again. That's it. It's up and running. Let's confirm. And there you go. It says that it was started 4 seconds ago. Okay, so I show you how to connect from Azure Data Studio, and we have been interacting with the container from my local machine. So what about connecting to the container, within the container, inside the container? So I can do it using this command, docker exec -it. The IT is the interrupted terminal that I'm going to use. Then I'm going to pass the name of a container, and finally saying, all right, I want to access this container using bash. So let's clear screen here again, and I'll run the command, and that's it. I'm inside the container. Let's take a look at the host name. As you can see, it's 20 years of pass. You can see that I am connecting as root. So that proves the container is up and running. What about running a query within the container? So let's do it. I will run this command connecting to using SQL command on this container and put in as a password. That's it. So let's run a couple of queries. Let's take a look at the server name again. There you go. And the version. I used the CU13, and I think this is the number. Yep. So that's it. Let's do something else. Oh, my bad. All right. So I want to see what containers are running on my machine, but not actually running. So I will run docker container ls. You can see my container is there. 20 years of pass is running. So let's imagine I don't want to use this container anymore. And so I'm going to delete the container using the docker remove and then name of my container. It says that I can't remove it because it's up and running. So I have two options. I can stop the container and remove it again, or I can force the docker remove command. I'm going to force the docker remove command using the -F here, which means force. And that's it. The 20 years of pass is gone. Let's confirm. Yep. As you can see, it's not here in this list anymore. All right. So let's move on to a most interesting demo. This demo is about a SQL Server upgrade. These are the steps. I'm going to pull some image, the image I'm going to use. And in this case, I will do an upgrade from CU13 to CU14 for SQL Server 2017 on Ubuntu. And these, of course, are optional because you can have it on your Docker cache already, so you don't have to do it anymore. Then I will create an inspect and volume. Remember, I told you during the slides that we were going to do that. We are going to create a volume. Then I'm going to connect to my my Linux kit that is kind of VM on a Mac, and you'll see the volume. We'll explore it, and then I will create a container running on CU13. I'll connect from Azure Data Studio. I will perform a restore. I will check the version. Then I'm going to stop that container to be upgraded to the CU13. Then I'll connect from Azure Data Studio. I will check the data files. I will make sure the database that I just restored is there. I will get the version also to make sure it was upgraded to the CU13. And this is an optional step that we can take a look at the SQL Server log and make sure everything went through, everything went fine during the upgrade. All right. So as I said, this is an optional step. If you have those images already on your machine, you'll get a message like this saying that it's pulling the image, but the image is already here. Image is up to date. It's fine. I'm going to do the same for the 14. I know it's here, but making sure, okay, everything is fine. Now, I'm going to list all the Docker images on my host machine. I can use the Docker image list, and you can see the output from here. But I don't like the way it is displayed on the screen. I want to see just the tag, which identifies the version, and I'm doing a sort. So using the awk and the sort command here. There you go. So I want to see if the CU13 and CU14 are here. Yes, making sure everything is fine. You can even do this image list to confirm that, or make sure you have the images, or just to clean up, do some clean up. For example, I have a very old images here, but I don't want to get rid of them because I am using for some more stuff. But anyway, you can use it to check what it's on your Docker cache. All right, so I'm going to proceed to create a volume. And in this case, I am deleting the volume first. I'm removing the volume, saying Docker volume, remove this volume. Just making sure that things are, oh, excuse me, things are clear. Yep, it doesn't exist. And also I will do a list. I want to see, okay, which volumes are hosted in this Docker. Okay, so I have some volumes here that existed before, some SQL data, some volume for some AGs that I had. All right, fine. I'm going to create a new volume. Done. So I created a volume saying Docker volume create and the name of my volume. Let's list the volumes again, and we can see my volume is here. All right. So what I'm going to do next, I'm going to open a new connection here, and I'm going to connect within the Linux kit virtual machine. I'm going to run it. I just run this command, and I'm going to press enter. There you go. So this is not my computer anymore. This is some kind of VM that was started when I started Docker. And let's see. Oh, before I go, that yeah, I'm going to do something really quick here. I'm going to do a Docker volume inspect, and I will pass the name of my volume. So you guys can see that the my mount point for this volume is this location, but this location doesn't exist on my computer. So that's why I connect to the Docker virtual machine to explore this mount point. So I will hop back to that session, and I will navigate here. And yes, it does exist. At this moment, it's empty because there is nothing in that volume. So I'm going to create, going to back here. Okay, so I'm going to create my first container. It's going to be named master CU13. The host name is the same. Again, just accepting the end user license agreement, my SA password. In this case, take a look at this. It's a little bit different. Now I'm saying, okay, I want you to use the volume version upgrade to mount this path within the container. What I'm doing here is making all my data files persistent. And then I'm using a share volume. I'm not sorry, I'm mounting a share volume between the container and my host computer. I'm saying, okay, I want you to use this path from my computer and map it as share on the container. The port I'm using is the 1401 and mapping to the 1433. And very important to note that I'm using the CU13 image. All right, so let's execute this and create this container real quick here. All right, done. Let's make sure. Again, you can use the Docker ps-a. I don't like the way this information is displayed, so I create this custom that does the same. All right, so master CU is up and running for the last 11 seconds. Great. So let's connect from Azure Data Studio, and I will take care of the restoration of my database. There you go. So it's up and running, and I can show you the connection. Okay, I previously created this connection, and I wanted to show you. Let's see if I can. Well, manage. Just do a different. Okay, there you go. So I created this profile before, and it says that it's using my local host connecting to a port 1400. I don't think this is correct because I'm using the 1401. So that wasn't correct. Let's fix it. All right, and the password and everything is provided already, and that's it. I am connected. So let's make sure this is connected to the right instance. Yep, fine. So what I'm going to do here is just a simple restoration of a database. As I said, I created a shared volume between the container and my computer, and I can show you guys that I have this is the shared directory between the Docker container and my computer, and I have this backup living here. So I'm going to use this backup to be restored. Let's run it. Okay, it's running. This is going to take probably 30 seconds to run, 30 to 25. Sometimes the time differs a little bit. So let's wait for this restoration to complete. Okay, all set. Everything was successfully completed in 29 seconds. Okay, let's run a query. I want to make sure I have this database. Excuse me. And yes, my database is here. It's called WWI. And let's take a look at the version of SQL Server. Okay, it says that my SQL Server is a developer edition 64 bits running on the version 14.0.3048.4, and that's equivalent to cumulative update 13. Okay, I'll leave this connection open, and I'm going to hop back to Visual Studio Code. Okay. All right, so what I'm going to do next is an patching, an upgrade from CU13 to CU14. So I'm going to stop my container really quick here. There you go, it's done. And now take a look at what I'm doing here. I'm using the same volume for the same path on my container, I'm doing the same. I am mapping directory from my computer to this directory from my computer to this mount point on the container. It's in the same port, but again, I am doing an upgrade, so I have to provide a different image, in this case CU14. So let's do it. Okay, it's done. This is going to take some time because SQL Server has to do the upgrade. There is a trace flag. I think it's 902. It's not documented. We can use to speed up this process a little bit more, but let's see. Okay, so remember that I have this connection on, yeah, it's CU13, CU14. That was the name I put it, and the port it's the 1401. Let's connect, and now expect this. It says SQL Server is running a script on upgrade mode, and only administrator can connect this time. This is normal. There's nothing to worry about. It is just saying, okay, SQL Server is doing the upgrade right now. So let's take a look really quick. I will connect to a Docker container again. Okay, I am in, and I'm going to take a look at the SQL Server error log live. Tail minus F. I will use the tail minus F to take a look at the error log. And there you go. He's doing a lot of stuff. He's creating views, dockering views. Let's try to connect again. It's not done yet. So as I said, this is not bad. It's fine, completely fine. He's doing what I'm expecting to do. Probably it's taking more time than I was expecting, but it's normal. Okay. Cancel. Right. 14. All right, so it's done. Let's go back here. And as you can see here, it says the recovery is complete. The upgrade was successfully complete. So let's make sure that's correct. All right. So I'm going to list the databases. Oh, excuse me. And yes, I have my database here, WWI. And let's take a look at the version. Okay, now the version has changed. It says 14.0.76.1, and the previous that I got was the 3048.4. So that means it was successfully upgraded. It took probably a minute. That's because of my computer, but I'm pretty sure in a better machine or server will run really quick. Okay. All right. So let's go back to presentation. But before that, something here. All right, all good. Let's go back. Okay, so here's a brief summary of some of the Docker client commands I used during the presentation. There is more, of course. You can take a look at Docker docs. There is a really good examples there. There is a lot of documentation around the command, so I truly encourage you to take a look if you want to learn more. Here's a few use cases for container. Obviously, local development testing. If you want to do something on your computer and you don't have a sandbox or I don't know, a server ready for you to use it, you can just span a container on your computer. You can do it yourself. Obviously, CI/CD and DevOps workflows. It really integrates very well with that. For troubleshooting, for example, you again you don't have a sandbox to test something, and you want to take a look at some issues. You can reproduce those problems using a container, for example. For demo purposes, you can build your own environment for demo purposes really quick. You don't have to deal with a lot of PMs and making sure you have enough space and stuff like that. No, that's gone. That's one of the use cases, really good case for use case for containers. And works really well to eliminate the resource management issues when it's caused by multiple teams working at the same time at the same instance. And I think sometimes sharing databases for development efforts sometimes it's not good. And it doesn't require an installation or larger times doing patching and stuff like that. So that's really convenient. Right, let's move on to Kubernetes. So here's the official definition of Kubernetes from Kubernetes docs. We're really short on time, so I'll skip this slide. And I'll start defining a little bit about the elements, the most important elements of the Kubernetes architecture. First, we have the master. It is the the brain of Kubernetes. It has multiple moving parts of processes running within. It runs on a single node within the cluster, and it simply tells all the nodes what to do. It it is the responsible to make sure the desired state we define it is in compliance. We have the nodes. They do simply do the work. They do run the applications. They were called minions in the past, which I like very much, but they changed it from minions to nodes. And these nodes report the state back to the master. As I said, the master will make sure the desired state is maintained, but the nodes will help him reporting that back to him. Then we have the pods. The pods are really important. It's where our containers are going to run. We can have one or more containers running on a pod, and these containers will communicate each other through the hostname within the pod. Then we have the services, and this is really great because pods are mortal. They born and they can die. When there is an issue with a pod, Kubernetes is not going to try to resurrect it. It's going to create a new one. So what will happen if we have our application point to a pod? That could be some kind of problem if we're using an IP or something like that and it's gone. So services fix that problem. A service will make the abstraction that defines a logical set of pods and a policy by access them, a policy which to access them. And sometimes it's called a microservice. This service provides obviously an IP address or a DNS that we can use for our application. And then we have deployments. Well, deployments is nothing more than a declarative model using a manifest file, can be YAML file or JSON. We're going to define what we want to implement in our deployment object, and the deployment controller changes the actual state to desired state at controller rate. And in our case, we're going to make a deployment of SQL Server on Kubernetes. And this is the some example of how we can use Kubernetes with a SQL Server. We have a user that is going to is going to be connected to a load balancer service. Remember, I just mentioned that. And this service obviously is mapped to a pod that we have SQL Server running on, and our data files and everything else, it will be stored in the persistent volume storage. So what happens when our node dies? When our pod, sorry, dies? Kubernetes simply will span a new pod, and the user won't notice because it it happens really fast. We'll have an example of that during the demo. Then let's imagine the pod has died and the node has died. So what Kubernetes is going to do is going to create that pod in a different node, and that's it. So it works pretty much close to what we're used to with the failover when the Windows failover cluster. Obviously different technology, but the logic behind is pretty much the same to understand it better. Some advantages of using Kubernetes: it's easy to use. It uses declarative configuration and language. It is a self-healing platform that has built-in HA. You can do auto scale. It is platform agnostic. It runs on Linux, but this host machine can be bare metal, can be Azure, can be a VM, or even OpenStack. The compute and storage layer are separate. If you remember from the previous slide, I was showing that we have this persistent volume that is not necessarily on the same host. It can be in Azure, in storage, it can be, I don't know, NAS, NFS. So we have different options there. It has load balancing out of the box. Remember, the service distributes the load for the application within the cluster, and obviously it integrates really well with CI/CD DevOps workflows. Let's have a demo. I think we have 4 minutes left. We can do it. And in this case, I will be using Minikube. That is the one node version of Kubernetes that you can use on your computer. I started this Minikube before. It takes a couple minutes, but I want to save some time. So I'm going to hop back here to demo number 4. All right. Okay, so I'm going to run like a few commands to make sure Minikube is it's good. And before I do that, I want to show you something really quick here. Remember that I told you that I was going to explore my volume within the VM to make sure everything was fine. So I remember I did the upgrade. So I want to make sure my data files is there. So remember I did this upgrade. And there you go. So the Y word imports that I call WWI, it's here. So everything that was created on my volume was upgraded from CU13 to CU14. Sorry about that, but I wanted to show you really quick. Okay, getting back to my screen here. All right. Okay, so I will take a look at the information for my Kubernetes cluster, and I will be using the kubectl commands. So I will run the kubectl cluster info, and that's it. It says my Kubernetes master is running on this IP under this port, so we're good to go. Then I want to take a look at how many nodes I have. In this case, I have only one node. Minikube just allows you to run one node. And I want to take a look at some pods. I already have one, which is a MS SQL deployment. And remember, I told you we can do deployments for Kubernetes using a YAML file. And this is it. Let me show you here. I don't have the time to go through all of this information, but I will go to the most important points. For example, the port 13.
Hi, Carlos.
Go
Sorry to
ahead.
interrupt you. We've got about 6 minutes and we still have a few questions coming through.
Okay, that's it. Oh, let me show you something really quick here. And I'll address this immediately. And I just want to show you that I can connect from SQL Server here from my computer, and this is running on Kubernetes. So excuse me, server name. And that's my deployment of Kubernetes. All right, and sorry I ran out of time. So we can address the questions now.
Okay, Carlos, we've had a few questions in, largely around disk layouts and named volumes. So one specific one was, can you specify multiple named volumes, one for data files, one log, one for tempdb, and have these volumes mounted on different physical volumes or mount points?
Wow, that's a really good question. I never tried before. I didn't have the need, but well, we'll have to take a look. We can discuss offline, but I never tried, but probably it's possible.
Okay, so following on
Oh,
from that,
yes, and I'm sorry. Yes, it's actually possible, but it
okay,
requires some modification to the image because we can create multiple mount points. We can create one for data files, one for the logs, but we'll have to modify the image, because the SQL Server default path for the data files it's on var opt ms SQL data and then logs. So we have to work that out on the image. But yes, it is possible. Sorry about
Cool.
that.
So following on from that, when would you prefer to use a named volume, and when would you use an unnamed volume? Are there any rules or anything around that?
Well, I always put a name. I don't think you can create a volume without a name.
Okay, so the specific example was like using your shared volume.
Oh yeah, that was a directory for my machine. You can put the name you want to use. In my case, I put share, but you can say, all right, host name or whatever you want. Yeah, it depends of your what you want to do. But yes, you can create multiple volumes for multiple paths from the host machine to a container, and you can name it the way you want, not only share.
Okay, excellent. And kind of an important one, inside the container, where are the system database files stored?
It was on the path that I showed. It was on the var opt ms SQL, then data, then logs. That's a default path from SQL Server running on Ubuntu. So this is an image based on Ubuntu, as I said. So it's a SQL Server instance running on Linux, in this case Ubuntu. So it's pretty much the same as a normal SQL Server instance that was installed manually on Ubuntu.
Okay, great. This is a kind of a side question. So that one of the attendees noticed that you had some containers with AG as container names. How did you get that working with AGs if we don't have clusters?
Yeah, so that's a really good question. So starting with SQL Server 2017, we have the option to create availability groups that are called read scale. These are not for HA purposes. This is for scaling up your readability of your databases. So I was able to create some read scale AGs on containers. And because these new AG type doesn't use a cluster. It uses a certificate between the instances. So it's really easy. I have some examples. If this person wants to ping me or send me an email, I will be more than happy to help him, and I can provide my scripts for him to create these AGs without a cluster. I think
Great.
during the AG configuration, you can specify the type. In this case, you have to use external, if I'm not wrong.
Fantastic. Thanks for that, Carlos. Right, I think that's about us done. We're out of time. If you could just wrap up on the slides. So coming up next in the 24 hours of pass, we have transforming your data estate, beating end of support for SQL Server 2008 R2. Stay tuned for that. That's with Raj Pojaratu and Pedro Lopez. Okay, I think we're good. Thank you very much for attending, and we hope you enjoyed the session. Thanks very much.